Hello everyone, I welcome you all for the second session of the first PUC practical session. In our previous session, we had find the diameter of the spherical body using vernier calipers. So that is the first part of the experiment. So the second aim of that experiment is to find or to measure the dimensions of a given regular body of known mass and hence to determine its density. So you know what is density? Density is equal to mass divided by volume. Okay? Volume is nothing but the multiplication of three lengths. So we have a regular body which is, so this is regular shaped body which is nothing but a rectangular block. So for this rectangular block, we need to find the three dimensions. What are those dimensions? As you can see here, this is nothing but a length of this block and this is the breadth and we have a height, or you can call this as a thickness also. So we need to find what are the length, breadth and height of this rectangular object using vernier calipers, and hence we need to determine the volume of this. Okay. So after finding the volume of the rectangular block, if I substitute the volume, the value of volume here, and the mass of that rectangular body can be found using a normal balance, so that you can find its density. So we need to measure the density of a given rectangular body or rectangular block using vernier calipers with the mass of that rectangular body is already known. Okay, this is the aim of our experiment. We know that for the vernier calipers, in our previous session only we had discussed about the specifications of the vernier calipers. What are the values of one main scale division, what are the total number of vernier divisions, and also what is its least count. That we have already explained in the last class. Let us write them again. This is your vernier calipers and we have two scales, as you already know this. This is a main scale and this one is a vernier scale. So what is the value of one main scale division in your vernier calipers? The value of one main scale division is 0.1 centimeter. So this has been already explained in the previous session. And the total number of divisions of the vernier. So you may find the divisions on this lower side of the window, and here there are totally 10 divisions we have counted in the last class itself, so that the total number of vernier scale divisions is 10. And how do you find the least count? Remember, what is a least count? A least count is the lowest possible measurement done by an instrument. So for the vernier calipers, we have a formula for finding the least count. What is that? Least count is equal to value of one main scale division divided by total number of vernier scale divisions. So the value of one main scale division, let us substitute that as 0.1 centimeter, and total number of vernier divisions is 10. So this is 10. So 0.1 centimeter divided by 10 will give us 0.01 centimeter. So now we had find what is the value of least count of the vernier scale, which is equal to 0.01 centimeter. Fine. So now using the vernier calipers, let us find what are the length, breadth and height of this rectangular body, and hence let us determine the density of this block by knowing the mass also. Okay. So now let us find the length, breadth and height of the rectangular block using the vernier calipers. So we have to make 3 trials for each dimensions. Okay. For length 3 trials, for breadth 3 trials, and for height 3 trials. Okay. Let us find out. Yes. First let us find out the length. So for finding the length, the object has to be kept in such a way that along this lower jaws you have to place this length. Means along this line you have to place the object. So we will place the object in this way. So you can see here this is a length. So we have to place this object along along this line. Slide the vernier slowly such that the object fits into the lower jaws. So the object is now fit into the lower jaws. Let us find out the readings now. So as we seen earlier, how do you find the readings of the vernier calipers. So we have to find the two readings here. First we need to find the main scale reading. So how do you find the main scale reading? Observe the 0th division of the main scale, and this 0th division is in between the two divisions of the main scale. So this is the 0th division of the vernier, 0th division of the vernier scale, and this division is lying between the two divisions of the main scale. Let us find out what are those two divisions. So this division is lying between 6.3 and 6.4 centimeter of the main scale. So you can observe here, this is 6, this is 6.1, 6.2, 6.3 and 6.4. So this division, 0th division of the vernier, lying between 6.3 and 6.4 centimeter. So as you know, we have to consider the least division, that is 6.3 centimeter is the main scale reading. Let us tabulate the first reading of main scale reading, that is MSR, for the first trial of the length. So this is found to be 6.3 centimeter. Okay. Then we need to find this CVD. What is CVD? CVD is coincided vernier division. So one of the division of the vernier scale is exactly coincided like this. Okay, it has to be collinear or coincided. So we need to find out of 10 divisions which division is exactly coincided with the main scale. So let us find out that. So if you observe the 0th division, the 0th division is in between the two lines. The next division, that is the first division, which is also in between the two lines, or it is very close to the next line. But the second division, if you observe the second division of this vernier scale is exactly coincided with the main scale. So this is 0, the next one is 1, the next one is 2. So this division, the second division, is exactly coincided. So consider 2 as CVD here. So let us tabulate the value of CVD for the first trial. So this will be 2. And now we need to find this TR. So what is the formula for finding this TR? TR is equal to MSR plus CVD into LC. Let us substitute the values of main scale readings, CVD and LC here. So the main scale reading for the first trial is 6.3 and CVD is 2 into least count. The least count is already known, which is calculated as 0.01. So this is 0.01. This is 6.3 plus 2 into 0.01 is 0.02. Now let us add these two. We will get 6.32 centimeter. Therefore, the first trial is found out to be 6.32 centimeter. So let us tabulate here. This will be 6.32. Okay. Well, so we have calculated the first trial of length. In the same way, we need to measure the main scale reading and CVD for 2 more trials. Okay, for the second trial and third trial. So let's find that. Now for the second trial, what we need to do is we have to just change the position of this object. Okay, but we need to measure the length only. Therefore, so while changing the position, you have to be careful that you need to place the object along this length only. You should not change the dimension to this. Okay, if you keep the object first along this position, next position should be here or here. So for the first trial, so we kept the object at this bottom edge. For the second trial, you have to keep the object at this center like this, and for the third trial at this edge. Okay, I kept the object at the center. Now we will find the readings, the main scale reading and CVD for this trial. Okay, now the main scale reading is found to be 6.3 again, and CVD is found to be equal to 1 here, and total reading is calculated using the same formula for the second trial. So the trial number 2. So let us write it directly. So this value will be equal to 6.31. So you should write the calculation. I am just writing the total reading for the second trial directly. So you should do in your books. Okay. So I have been not doing this calculations here. You should calculate this one using the same formula. Okay. Now let us look out the third trial just by changing the position of the object again. So I have slightly changed the position. So I have placed the object at the upper edge now. Now the readings for the third trial is turn out to be, the main scale reading is 6.3 and CVD is equal to 2. So if I calculate this one, we will get 6.32 centimeter. Next, we need to find the mean TR in centimeter here. So mean TR means you need to add these 3 and divide it by 3. So let us do that. So if you find the mean TR, that is by adding these 3 and divide it by 3, what we will get is 6.3166. If I round it off to the second decimal place, what I will get is 6.32 centimeter. Okay, so this is the value of mean TR. Now the second dimension. So for the same object, we are changing the dimension to breadth now. So how do you find the breadth using the vernier calipers? So you can see here the breadth is marked as B here. Okay. Now you have to place the object along this line or along this breadth. Okay. Let us place the object along this breadth now. I am placing the object like this and slide the vernier towards it. Let us find out the main scale reading for the first trial. This is the 0th division and this 0th division is in between. This 0th division is in between 7.6 and 7.7. The least division is 7.6. So you should consider 7.6 centimeter as MSR. Let's find the CVD now. This 0 division is almost near, but the first division, so this division is exactly coincided with the main scale. That is why CVD is now considered as 1. Let's tabulate the values now. So this is equal to 7.6. This is 7.6 and the CVD is 1. And let's find out the total reading for the first trial for breadth. For the trial 1, total reading, the main scale reading is 7.6 plus CVD is 1 into least count is 0.01, and if you do this one, you will get 1 into 0.01 is 0.01, and if you add these two, you will get 7.61 centimeter. Therefore, the total reading for the first trial is 7.61 centimeter. Let us tabulate this. This is 7.61 centimeter. Now, let us find the mean scale reading and CVD for the 2 more trials. Okay, for the second and third trial by changing the position of the object. Now, let us change the position slightly. And do not forget that you should always keep the object along this breadth only. While calculating the breadth, you should always keep the object along the breadth. Now let us find the values of main scale reading and CVD. Now if you observe the 0th division of the vernier, this division itself is exactly coincided with the main scale division, correct? So if you observe this 0 division, the 0 division is exactly coincided with the main scale division. So in this case, main scale reading is considered as 7.6 centimeter only because it is coincided with 7.6 centimeter. And CVD is considered as 0 here. Okay, CVD should be considered as 0. Let us tabulate the readings. Main scale reading is 7.6 and CVD is 0. And if I calculate this one, we will get this as 7.60 centimeter. Next, for the third trial, let us change the position of the object and find out the third trial. I will be slightly changing the position to the edge and let's find out. The main scale reading is 7.6 and the CVD is 1 in this case. Let me tabulate this. The main scale reading is 7.6 and CVD is 1. Therefore, the total reading will be 7.61 centimeter. Now, let us find out the mean value of this by adding these 3 and divide it by 3. So, you will get 7.6066 recurrence. So, if you round off to the correct decimal places, you will write this as 7.61 centimeter. Okay. Now, let us find the third dimension, that is height. Okay. Now, we need to find this height. Okay. So, how do you find this height? The object is now placed in such a way that it should be along this line, okay, along the height. So, how do you place this? Like this, you have to place the object by sliding the vernier towards it. Now, let us find out the main scale reading and CVD for this trial. Observe the zero division. The zero division is in between 1.9 and 2. So least division is 1.9. Therefore, MSR is 1.9 centimeter. And let's find the CVD now. CVD is the first division. After the zero division, the first division is coincided with the main scale division. So 1 is CVD in this case. Let's tabulate the readings. This will be 1.9 and CVD is equal to 1. So the main scale reading is 1.9 centimeter and CVD is 1 for the first trial of height. Let us find out the total reading. The total reading for the first trial, MSR is 1.9 plus CVD is 1 into least count is 0.01 and this is 1.9 plus 0.01. If you add these, you will get 1.91 centimeter. Therefore, the total reading is 1.91 centimeter. Let us write this 1.91 centimeter. Now, let us find the second and third trial by changing the position. Now, I have slightly changed the position along the height. Let us find out the main scale reading and CVD here. Again, the zero division is in between 1.9 and 2. Therefore, 1.9 centimeter is main scale reading and the CVD is 1 and this is 1.9 and CVD is 1. The total reading will be 1.91 centimeter. And for the third trial, let us change the position again. So I have slightly changed the position now and find out the main scale reading and CVD here. Main scale reading is again 1.9 centimeter and CVD now is 2. The main scale reading is 1.9 and CVD is 2 and therefore the total reading will be 1.92 centimeter. So if we find the mean value of these three trials, what you will get is 1.91. Okay. So we have calculated the values of length, breadth and height. The mean values of length, breadth and height are considered as the true values. Let us write it together. The mean length is equal to L, which is equal to 6.32 centimeter, and this is converted to SI unit by multiplying 10 power minus 2. Okay, this is 6.32 10 power minus 2 meter. Next, mean breadth is equal to B, which is equal to 7.61 centimeter, that is equal to 7.61 into 10 power minus 2 meter. Then mean height will be equal to H, that is equal to 1.91 centimeter. This is 1.91 into 10 raised to minus 2 meter. So we have calculated the values of L, B, H, that is length, breadth and height. Now, what is the aim of our experiment? We need to find the density of that rectangular block. So for finding the density of that rectangular block, what we need is its mass and volume. So how do you find the volume of the rectangular body? The volume of the rectangular body is equal to length into breadth into height. Okay. So now let us do the calculations of volume. Volume of the rectangular body, V is equal to L into B into H. V is equal to L into B into H. Let us multiply this in SI units. This is 6.32 into 10 power minus 2 into this is 7.61 into 10 power minus 2 into height is 1.91 into 10 power minus 2, and if you multiply this, what you will get is 91.86 into 10 power minus 6. So here you have 10 power minus 2 into 10 power minus 2 into 10 power minus 2. Therefore, this becomes 10 power minus 6. So we have just multiplied these numbers. Okay. And the unit of volume is meter cube. Now, we need to find the density. So how do you find the density? The formula for density is mass by volume. Now, mass of the rectangular block, which is equal to M. So let's find the mass of this rectangular block using this weighing balance. So the reading is turned out to be 0.073 kg. Let us write the value of mass. The mass is found to be 0.073 kg. Now let us find the density of the block. Density is given by mass divided by volume, m by v. So the mass is equal to 0.073 divided by volume is calculated, which is equal to 91.86 into 10 power minus 6, and if you divide 0.073 by 91.86, you will get 0.0007946. So we have 10 power minus 6 here. If you take this 10 power minus 6 to the numerator, it becomes 10 power plus 6. So this into 10 power 6. So let us write this as 794.6. So I have shifted this decimal towards the right side so that we have to decrease the power. So we have power 6 here. So shift this decimal towards the right side by 6. Then this 10 power becomes 0, which is equal to 1. So 794.6. 794.6. The unit is kg per meter cube. So this is the density of that rectangular block. So 794.6 kg per meter cube. Next, let us write the final result of the experiment. So the result of the experiment is length of the rectangular body L is equal to 6.32 into 10 power minus 2 meter. Breadth of the rectangular block B is equal to 7.61 into 10 power minus 2 meter. Height of the rectangular block H is equal to 1.91 into 10 power minus 2 meter. Then finally, density of the rectangular block rho is equal to 794.6 kg per meter cube. Now we have completed finding the density of the given rectangular block using vernier calipers. Now we are left with finding the internal volume of the given hollow cylindrical object. Now the third object is a calorimeter. So this is your calorimeter. See, this is your calorimeter. So you have to find the internal volume of this calorimeter. A calorimeter is an hollow object. So you can see an empty space here. So the cross section looks like a circle. So first we need to measure what is the diameter, the internal diameter of this cylinder. Then what is the depth of the cylinder, the internal depth, like from here to the bottom of this cylinder. So this length we have to measure here. So what are the lengths we have to measure here? So if you look at the cross section of the calorimeter, the cross section looks like a circle, and we have to find this internal diameter, and then we need to find the internal depth, that is from this point to the end of the cylinder. Okay. Now how to keep the object to find the internal diameter? So first we need to measure the internal diameter. So how do you measure this internal diameter? So for this we have to use these upper jaws. Up to now we will be using the lower jaws of the vernier calipers. Now we have to use the upper jaws. So how do you keep the object? See, the object has to be kept like this until the two knives should touch the edges of the cylinder. So you have to keep the object like this, and you have to make an adjustments such that those two knives should touch the edges of a cylinder. Then tighten this, and now let's look at the reading. Now if you observe the zero division of the vernier scale, which is lying between 4.7 and 4.8 centimeter of the main scale. So we will be considering 4.7 centimeter as main scale reading. Okay. Next, now let us look at the CVD. So this is the zero division, and if you observe the seventh division, so this division, the seventh division is exactly coincided with the main scale. So we will be considering CVD as 7 here. Let us tabulate the readings. The main scale reading is found to be 4.7 centimeter for the first trial, and CVD is equal to 7. Let's do the calculations for the first trial. For trial number 1, total reading is equal to, we have a formula for finding the total reading. TR is equal to MSR plus CVD into LC, and we know the value of LC is 0.01 centimeter. Now let us substitute these values. MSR is 4.7 and CVD is 7. MSR is 4.7 plus CVD is 7 into least count is 0.01. Now keep this as it is and multiply these two. So you will get 0.07. 4.77 centimeter. So you will be getting the total reading for the first trial as 4.77 centimeter. Let us write that. This is 4.77. Next, for two more trials, we need to change the position of the object. By changing the position of the object, we have to find these readings now. Let us find out. Now let us change the position. First I have kept like this. Now I will slightly change the position of the cylinder and I will keep along the diameter only. So place the object such that the two edges or the two knives touches the edges of the cylinder. Yes. Let me look at the reading again. So the main scale reading is 4.7 and the coincided vernier division is 6 now. Let us tabulate that. The main scale reading is 4.7 and CVD is 6 here. Therefore, we will get the total reading as 4.76. I am not doing the calculations of these two trials. You can do on your own. Next, third trial. Again, I will be changing the position and I will keep the object like this and I will tighten this. Now for the third trial, the main scale reading is 4.7 centimeter and CVD is 5. Let us tabulate the readings. This is 4.7 and CVD is 5. Therefore, the total reading will be 4.75. Now let us find the mean TR for these three trials. 4.77 plus 4.76 plus 4.75 whole divided by 3. What you will get is 4.76 centimeter. Now we have to find the internal depth of the cylindrical object and let us do this calculations. Okay, main scale reading and CVD for this dimension. Now the second dimension we need to find here is the internal depth. So what is that internal depth? So I already explained you that the distance from this point to the end of the cylinder or to the bottom of the cylinder. So how do you find this? Now we have to use this strip. Okay, so till now we are using this lower jaws and upper jaws. Now for finding the internal depth of the cylinder, you need to use this strip. Okay, so how do you use this? Now place the edge of this main scale to the top of the cylinder and you have to scroll down the strip till the tip of the strip touches the bottom of the cylinder. So you have to place the object like this such that the edge of the main scale touches the upper end of the cylinder and the tip of the strip touches the bottom of the cylinder. And again you have to look at the readings in the same way what you have done in the last time. Okay. So if you observe the 0 division of the vernier which is coincided exactly with 7.0. So you should consider 7.0 centimeter as main scale reading, 0 as CVD. Let's tabulate the readings now. The internal depth for the first trial is 7.0 centimeter. Sorry, main scale reading is 7.0 centimeter and CVD is 0 in this case. If you find the TR for trial number 1, the total reading is, let us use the same formula, MSR plus CVD into LC and main scale reading is 7.0 plus CVD is 0 into least count is 0.01. Therefore, this will be 7.0 centimeter. Therefore, the total reading is equal to 7.0 centimeter. Let us write this. Let us find the main scale reading and CVD for two more trials. Now keep the strip inside the cylinder and scroll down till the main scale, the edge of the main scale touches the upper edge of the cylinder and the tip of the strip touches the bottom. And let us find out the main scale reading and CVD for this. Main scale reading is 7.0 centimeter and CVD is 4. Let us tabulate this. The main scale reading is 7.0 centimeter and CVD is 4 and the total reading will be 7.04. Now for the third trial, let us do it again. Just change the position and keep the strip inside the cylinder till it touches the bottom and main scale, the edge of the main scale touches the upper edge of the cylinder and find out the reading. Main scale reading is 7.0 and CVD is now 3. This is 7.0. So the CVD is 3 in this case and if you find the total reading, it will be 7.03. So let us take the average of this, the mean value of this 7.00 plus 7.04 plus 7.03 whole divided by 3. What you will get is, so you will get 7.023, and so if you express the final result in appropriate significant figure, you will get 7.02 centimeter. So now we have got the values of internal diameter and internal depth. But the aim of this experiment is to measure the internal diameter and depth of a given calorimeter and hence to calculate its volume using vernier calipers. So we have calculated the values of internal diameter and internal depth, but we need to find its volume. Now let us write what are the values of internal diameter and internal depth. Mean internal diameter D is equal to 4.76 centimeter. So this is converted into SI unit by multiplying 10 power minus 2. Okay, therefore 4.76 into 10 power minus 2 meter. And this is internal depth, which is represented as H, which is equal to 7.02 centimeter and 7.02 into 10 power minus 2 meter in SI units. Now let us do the calculations of volume. The internal volume is given by pi d square H divided by 4. So this is the formula for finding the internal volume of the calorimeter or a cylindrical object. Pi is 3.14 into d square. D is 4.76 into 10 power minus 2. Let us substitute that. This is 4.76 into 10 power minus 2 whole square into H. H is this 7.02 into 10 power minus 2 meter. So this is 7.02 into 10 power minus 2 whole divided by 4. So if you do the numerator, you will get 499.44. So here you have 10 power minus 2 square. This will become 10 power minus 4. And here we have 10 power minus 2. So if you multiply this, you will get 10 power minus 6. Therefore the numerator, in the numerator, we have 10 power minus 6. This divided by 4. And if you divide this, so the final answer will be 124.86 into 10 power minus 6. So the unit of this volume is meter cube. So finally, we find the value of internal volume of calorimeter. So that object is called as a calorimeter. It is a hollow object. So you can see here, this is an hollow object. Hollow means there is an empty space inside. So we have find the value of this internal volume using a vernier calipers. And the answer is found to be V is equal to 124.86 into 10 power minus 6 meter cube. So the final part of the experiment, let us write the result. So the result of the experiment is the internal diameter of the calorimeter D is equal to 4.76 into 10 power minus 2 meter. Then internal depth of the calorimeter H is equal to 7.02 into 10 power minus 2 meter. And finally the internal volume of the calorimeter, that is equal to V, which is 124.86 into 10 power minus 6 meter cube. So that's all for this session. In our next session, we will be doing the second experiment, that is screw gauge. Thank you.